teaching you two different ways. One way is going to take a little bit longer, but some of us will like it more because it's going to relate closely to what you do in biology. Have y'all done the Punnett squares before? Doing genetics? Yes? So that's the first method. All it is a graphic organizer, okay? So we're going to use what we call the box, not the Punnett square. We call it a box. We're going to use a box to help us multiply our polynomials, and then we're going to do something else without making the box. Again, on our notes, do it the way I do it. First use the box, then don't use the box, and then whenever you do your your homework, quiz, test, do whatever you want that works best for you, okay? But I want you to practice both so you can figure out which one's going to work best for you. So, we're going to multiply with binomials. Bi means how many? 2, so 2 terms. You're going to distribute each term in the first binomial to each term in the other binomial, and then combine like terms. Okay, so our first step is to determine how many terms there are. In this first parenthesis, how many terms are there? 2, the b and the -4. How many terms are in the second parenthesis? 2. This helps us figure out the dimensions of our Punnett square. 2 terms times 2 terms. So we're going to draw a 2 by 2 box. When you draw your Punnett square, it needs to be not huge because we're going to write stuff outside, but it needs to be big enough that we also can write stuff inside. So kind of see how I did my box, okay? It needs to be big enough to where I can write stuff inside, but don't take up the whole space where you can't write anything outside. Notice the dimensions of my box. 2 columns by 2 rows, because I'm doing 2 terms times 2 terms, okay? So I am going to label the outside of my box / Punnett square with the terms in my parentheses. Okay, it doesn't matter if you put your first parenthesis on the top of the box or the first parentheses on the side of the box. You just have to stay consistent. The whole first parenthesis needs to go on top or on the side. You can't put like the first term on the top and the second term on the side. Okay, so I'm going to put my first parentheses on top. So B is on top of my first column. -4 is on top of my second column. Then my second parenthesis, I'm going to label the sides of my box. B and then 6. Do I need to put the +6? Or if I have a 6, is it understood that it's positive? Understood that it's positive. So I don't need to put the plus in front of the 6, okay? Is it wrong if you do? No, but it's just going to save you some space. Okay? Now again, this is exactly like you did your Punnett squares. Fill in the columns. Both of these boxes are in what column? What's this column labeled? B. So I'm going to put a B and a B. These 2 boxes are in what column? What's the title of this column? So I'm going to put -4 in both of these columns. So I labeled my columns. Both these were in the B column, both of these were in the -4 column. Now I need to label my rows. Both of these are in the B row. And we're going to write times B. So we're multiplying. Then what's the label for this row? So I'm going to put times 6. So all of my boxes should have 2 factors in there. Okay? One for the row it's in and one for the column it's in. Okay? So, again, this is just our graphic organizer. We are now going to take the terms out of our box. What is B times B?
B squared.
B squared. BB gives you B squared. What's -4 times B? -4B. What's 6 times B? And if it's a positive, what needs to go in front of it? Because we use what to separate our terms? plus and minuses. So plus 6b. Good job. And then the last box is negative 4 times 6. Negative 24. Okay. So, the boxes represent the factors that you're multiplying together. Okay. Then when I take them out, they're now my terms that we are adding and subtracting. Okay. Do I have any like terms here? What? So what's negative 4b's plus 6b's? Positive 2b. Does it become 2b squared? No, because when you add and subtract, exponents don't change. Drop down your b squared and drop down your minus 24. Do I have any like terms? Am I in the correct order of b squared, b constant? We are done. Okay, how many of us like when we can use the calculator to check ourselves? Don't we like knowing when we get the right answer? I do. Especially, guys, on your test when they're multiple choice. Okay, so let's all do this with me. Go to your calculator. Again, these new calculators have the same functions as the old ones. Top left button is your y equals. Clear whatever is there. Top left button is your y equals. I'm going to put in my original problem, but remember, you can't graph b's. I need to change those to what variables? X. So I'm going to do parentheses, x minus 4, parentheses, x plus 6. We good with that? Now, arrow down, and I'm going to put x squared plus 2x minus 24. This is called factored form. This is called simplified form. Because remember, when we simplify, you're wanting to get rid of parentheses. This is factored form, two things multiplied together. So these are not different problems. They're just represented in different forms. But they should be exactly the same. Okay, did we all type both in? Hit graph. Do you see why I like these? The colored ones more? You had the blue one graphed, and then that blue then was outlined in red. Are these the same exact shapes? Yes, because you did it right. These are equivalent to each other. Another way you can check is do second graph, which is the table, and do the y values all match up? Because they are the same functions. Okay? What if they didn't match? You're wrong. Okay? If they don't match, you are wrong. Good? Again, the only thing that you can't do it is whenever you have more than one variable, you can't check. And you have to change whatever variable you have to x instead of whatever is given to you. But they matched when we graphed them, so we are correct. Good job, us. Okay? Guys, these are super procedural. We're doing the same exact thing every single time. We first start by, how many terms do I have in my parentheses? 2 terms. So that's 2 terms times, how many terms do I have in my second parenthesis? Also 2. So that's a 2 by 2, so I'm drawing a 2 by 2 Punnett square. Then I'm labeling my Punnett square. D and 2, D and negative 5. If you flip-flop yours and put the first parenthesis on the side and the second parenthesis on top, we'll get the same exact answer. Just these 2 middle boxes, diagonals, will be flip-flopped, but you'll get the same exact thing as me. Okay? So label your column. These 2 are both in the D column. These 2 are both in the 2 column. These 2 are both in the D row, so times D times D. These 2 are both in the negative 5 row, so times negative 5 times negative 5. Biggest mistakes, guys, is really when we do our constants, we see 2 minus 5 and we write negative 3. The terms inside the box, we're multiplying these to then take them outside the box, okay? So what's d times d? D squared. What's 2 times d? So plus 2d, because we have to have plus and minuses to separate our terms. D times negative 5. Because we always put coefficients before variables. Good job. And then 2 times negative 5. Negative 10. Do I have like terms? Normally, guys, your middle terms will be like terms. Okay? I'm not going to say always, but like a lot of the time. So what's 2d's minus 5d's? Thank you. Negative 3d. So drop down your d squared and drop down your minus 10. Do we have any like terms? Are we in the correct order? D squared, d constant? Yep. Okay, we're only going to check one more of these on the calculator because we're doing them together. I know we're getting them right, but I do want you to get in the habit of checking. So let's go to our calculator, go to y equals, clear it out. Okay, so go to y equals and clear it out. Parentheses, x plus 2, parentheses, x minus 5. X squared minus 3x minus 10. The original in y1, the new one in y2, and graph it. Blue, red, they're on top of each other. So did we get the right answer? Yep, yay. After doing just 2 of these, guys, how do we feel? Pretty good? Do we like that it carries over from what you did in biology? Does it make it filling in the boxes a little easier? It doesn't. Some of us does it. You might like the other method then, Syra. We're going to do 4 more with this method, but then I'll show you the other method, which is the same exact thing. It just doesn't have the box. Okay. So we always start. How many terms in the first parenthesis? In the first parenthesis? Remember, terms are broken up by addition and subtraction signs. 2 terms. You have your 3a and your negative b. How many terms in the second parenthesis? 2. Your a and your negative 2b. I will tell you, this one you're going to need to make your box a little bit bigger, like a little bit wider, because you have multiple variables now. So I did a 2 by 2 box because it's 2 terms times 2 terms. Morgan. I know the Odyssey is like so intriguing. Is that what y'all are reading now in English? Did y'all just start it? Well, obviously we just started this semester. That wasn't a smart question. Okay, 3a, negative b. A, negative 2b. Fill in your columns. These are both in the 3a column. These are both in the negative b column. Then fill in your rows. These are both in the a rows. And these are both in the negative 2b rows. This one is a little bit trickier. What's 3a times a? 3a squared. Great job. What's negative b times a? Negative. Y'all are kind of talking soft. Negative what? Okay, so you could write BA, but I think last class we talked about it a little bit. Just like we put our exponents in order from big to small, we put our letters or variables in alphabetical order. So I would write minus AB. If you write minus BA, that's not wrong because when you multiply, order doesn't matter, but you're going to see it as minus AB. And then what's 3A times negative 2B? Great job, negative 6AB. And then what's negative b times negative 2b? Negative, negative. Positive, because a negative times a negative is positive. What's the only coefficient? What's the only big number? 2. How many b's do you have? So b squared. Now, do I have like terms? Yes. This AB doesn't have a coefficient, so what am I going to put there? 1. So drop down your 3a squared. And then what's negative 1 minus 6? Good job. Negative 7ab. And then drop down your plus 2b squared. Are any of those like terms? No. Are we ready to try one on our own, guys? I think so. I want you to try number 4 on your own, please. We have 2 terms times 2 terms. I'm going to draw my 2 by 2 box. I have an x and a 6. I have an x and a negative 6. My second 6 has a minus in front. Both these are in the x column. Both these are in the 6 column. Both of these are in the x row. Both of these are in the negative 6 row. Take our terms out. Xx becomes, very good, 6 times x is, and it's a positive, x times negative 6, and then 6 times negative 6. My middle terms are like terms. What's 6x's minus 6x's? No x's. Gone, gone. So I am just dropping down my x squared minus 36. So that one was kind of tricky with the middle terms canceling out. Okay. Do we have questions over that one? Okay. Next one. Parentheses to the second power. Well, I don't know the dimensions of both of my sides of my box. A lot of us like to just distribute that exponent to the a and to the 1, because that's what we've been doing whenever we've been doing our exponent properties. However, when we were doing our exponent properties, there was only one term in the parentheses. Is there only one term in the parentheses now? No. So if you distribute that exponent of 2 to the a and to the 1, you're going to get it wrong. You're going to miss your middle term. Okay, so from our exponent unit, what do we say something to the second power means? So you have the parentheses twice. So I'm going to write this out as a minus 1 times a minus 1. You have the parentheses twice. So I have 2 terms times 2 terms. So a and minus 1, a and minus 1. Fill in your a column. Fill in your negative 1 column. Fill in your a row. Fill in your negative 1 row. Okay, now let's take our terms out. What's a times a? A squared. Great job. What is negative 1 times a? Negative 1a. What's a times negative 1? Negative 1a again. And then what's negative 1 times negative 1? Positive 1. Negative, negative is positive. Are my middle terms like terms? What's negative 1a minus 1a? Negative 2a. They don't cancel because they're both negative. So you add the numbers. 1 plus 1 is 2. They're negative, so it's a negative 2a. Remember, when you add and subtract, your exponents do not change. So let's compare our answer with what would happen if we just distributed that squared. What's a squared? Just a squared, right? What's negative 1 squared? What's negative 1 times negative 1? Negative, negative? 1. Positive 1. So if I just square both my terms, I get my first term and I get my last term, but I would be missing that middle term, which makes your answer wrong. Okay? We good? Now, I'm going to make it one step harder. And not harder, just longer. And when things are longer, sometimes we make more mistakes. But the same process, guys, same process, okay? How many terms in my first parenthesis? 2. Times, how many terms in my second parenthesis? 3. So am I going to make a 2 by 2 box this time? No, I'm going to make a 2 by 3 box. I'm going to do 2 tall and 3 long. Does it matter which way you make your box? You could do 3 tall and 2 long. Now this one, does it matter which place you put your terms? Yeah, the 2 term parenthesis has to go on the 2 box side. The 3 term parenthesis must go on the 3 box side. Okay? So I'm going to put my x and my 3, x squared 2x and negative 5. Okay, just like we did before, label your columns. X squared column, 2x column, 2x column, negative 5 column, negative 5 column. Then we're going to label our rows. Times x, times x, times x. Those are all in the x row. Then times 3, times 3, times 3. Those are all in the 3 row. Okay, now we're going to do the same thing. Take our terms out of the box. What's x squared x? Great job, x to the 3rd power. And I'm going to go down. What's x squared 3?
3x squared.
And it's a positive, so plus 3x squared. What's 2x times x? And plus, because it's a positive. Good job. What's 2x times 3? And it's a positive, so plus 6x. What's negative 5 times x? And then what's negative 5 times 3? Negative 15. What's 2 times 3, guys? 6. 1, 2, 3, 4, 5, 6 terms. I have 6 terms. Okay, but now we're going to combine like terms. Do I have a like term with my x cubed? Nope, drop it down. Do I have a like term with my x squared? Yes, yes ma'am. I don't know. Thank you. Because I'm so used to writing x squared. Do I have a like term with my 3x squared? What? Very good. So what's 3 plus 2? So plus 5x squared. Remember, when you add and subtract, exponents don't change. Do I have more like terms? What? So what's positive 6x's minus 5x's? And do I need to put the 1? No, I'm just going to put plus x. And then do I have a like term with my constant? No, negative 15. Good? How do we feel about the box? Good? Okay. Now, I'm going to tell you, the next way I'm showing you, we're doing a lot more just in our head. Okay? Now, that obviously makes the process a lot shorter because we don't have to draw the boxes. Okay, so most of us are probably going to say, yes, we like this next method the most. However, if you're not getting them right, because you have to do a lot more in your head, you don't visually see it. So if you're not getting them right, use the box. Yes, the box takes longer, but wouldn't you rather take longer and get it right than go fast and get it wrong? Okay? Some of us might be able to do this next method perfect every time. Okay? It's just a different way our brains work. Okay. How many terms in the first parenthesis? 2 times how many in the second parenthesis? 2 times 2 is 4. So I have to distribute 4 times, okay? If you choose this method, please, please, please draw your distribution arrows because we're distributing 4 times, so you should have 4 arrows, okay? So I'm going to take my 2x, my first term, and multiply it by the first term in my second parenthesis. I'm distributing it. What's 2x times 2x? 4x squared. 2 times 2 is 4. X is x squared. So 4x squared. Now I'm going to distribute my 2x to the second term in the second parentheses. So what's 2x times negative 5? Negative 10x. Did I distribute my 2x to both terms in the second parenthesis? So we're done with the 2x. Okay. Now we're going to move on to our 5. 5 times 2x. And it's a positive, so plus 10x. And then distribute your positive 5 to your negative 5. What's 5 times negative 5? Negative 25. Guys, do you see how essentially this is the same exact thing as drawing the box? How many terms did I get? How did I get these 4 terms? By multiplying these terms by these terms, which is what we did when we did the box. It's just I'm not drawing the box. I'm just doing the multiplying in my head. Okay? Just like when we did the box, do I have like terms? Yes, my middle terms are like terms. What happens with negative 10x plus 10x? Cancel. And I get 4x squared minus 25. So guys, did this take a lot shorter time? Yes. But do you think that you could make a lot of silly mistakes doing this in your head? Yes. Okay. Questions? I cannot stress enough, draw the distribution arrows. Okay, some of y'all are lazy and you don't like to do that. If you're going to be lazy, choose this method. But please draw the distribution arrows. Okay. Next one, how many terms? Times 2. So I need to distribute my x to my x. What's x times x? Then I need to distribute my x to my negative 4. Then I need to distribute my negative 10 to the x. Negative 10x. And be careful, that's a negative 10 because there's a minus in front of it. So what's negative 10 times negative 4? Positive 40. Do I have like terms? Yes. What's negative 4x minus 10x? They're the same sign. They're both negative. So what's 4 plus 10? 14, and they're negative, so negative 14x. Drop down your x squared. Drop down your plus 40. Are any of those like terms? Nope. Are we in the correct order? Yep. There's my answer. After doing 2 of these, who likes these better? Almost all of us. Okay. So what I'm going to tell you, if you're using this method, I'm good with that. If you get a problem wrong, let's say, if you get 2 problems wrong, go back to using the box. Okay, we like this method because it's faster. You don't have to draw a box. I think the box is better for a lot of us because you're less likely to make silly mistakes. So if you get 2 problems wrong doing it this way on your own, go back and see if the box actually is better for you. Okay, sound good? Next one. How many terms? Times 2. So I need to distribute 2 times 2, which is 4 times. So what's n times 5n? 5n squared. What's n times negative 4? Negative 4n. What's negative 1 times 5n? Negative 5n. And what's negative 1 times negative 4? Plus 4. Do I have like terms? Yep, the middle terms are like terms. What's negative 4 minus 5? Negative 9n. Drop down your 5n squared and drop down your plus 4. Are any of those like terms? No. Okay, I want y'all to do number 10 on your own. After you get your answer for number 10, graph both of them. Okay, put them in your calculator. Make sure that they are equivalent to each other. Do number 10 on your own, please. Okay, guys, let's look. Walked around, I saw lots and lots of good stuff. I saw a couple of silly mistakes, but common silly mistakes. 6a times 2a is squared, because AA is a squared. When you multiply, exponents change. What's 6a times positive 3? And it's a positive, so plus 18a. 2 times 2a, so plus 4a, very good. And then 2 times 3 is plus 6. Do I have like terms? My middle terms are like terms. When you add, do exponents change? Nope. What's positive 18 plus 4? Positive 22a. Drop down your 12a squared and drop down your plus 6. Are any of those like terms? No. Are we in the correct order? Yep. A squared, a constant. Good? Are we thinking that today's lesson isn't too bad? Any of us like it? I think it's kind of fun. But then again, I chose to do math every day of my life as my job, so probably would like it. Okay, again, you cannot just distribute that exponent of 2. You only can distribute exponents to everything in the parentheses when there's only one term in the parentheses. There's 2 terms in the parentheses. So I need to write my parentheses out twice. 2m minus 5 squared means 2m minus 5 times 2m minus 5. So I have 2 terms times 2 terms, which is 2 times 2 is 4, so I need to distribute 4 times. So what's 2m times 2m? 4m squared. What's 2m times negative 5? What's negative 5 times 2m? And then what's negative 5 times negative 5? Positive 25, so plus 25. Very good. Are my middle terms alike? What's negative 10 minus 10 more? Negative 20m. Drop down your 4m squared and your plus 25. Is anyone noticing kind of a pattern with most of these problems? I'm not going to say all, but most of the ones we're doing, what are we noticing the pattern is? My first term is going to be squared. My middle 2 terms are going to be like terms, and they're both just going to have the variable, and then the last term is the constant. My middle terms combine, and then my answer is variable squared, variable, no variable, constant. Okay? Is it always going to be like that? No, but if we've done on this page 5 problems and all 5 are like that, do you think it's pretty common that it's going to be like this? Yes. Okay. We good? Ready for our last one? This one's going to get a little messy because we have what? 2 times 3. What's 2 times 3? So how many distribution arrows do I need to draw? 6. I'm distributing 6 times. Okay? So what's 2x times 2x squared? 4x to the third. 2 times 2 is 4, and then x squared is x cubed. What's 2x times negative 3x? Negative 6x squared, because the 3 is negative. So negative 6x squared. And then what's 2x times 1?
2x.
So plus 2x. So did I distribute the 2x to all of the terms in the second parenthesis? Yep. Now let's move on to our negative 1. What's negative 1 times 2x squared? Very good. Then what is our negative 1 times negative 3x? Plus 3x. And then what is my negative 1 times positive 1? Negative 1. So now this looks like what we did on day 1. We need to write it in the correct order and combine our like terms. What's my biggest exponent? 4x cubed. Cubed is my biggest exponent. There's no like term with 4x cubed. Done. What's my next biggest exponent? X squared. So I have negative 6x squared. Is there another x squared term? Negative 2x squared. So what's negative 6 minus 2? Negative 8x squared. Keep it x squared because when you add and subtract, exponents don't change. Then I have a plus 2x. Is there another term to combine that with? This one's the next term. Plus 3x. So what's 2 plus 3? So plus 5x. And then last but not least, your constant, which is minus 1. Okay, so when we are doing our homework, guys, a lot of y'all said you prefer this. We call this double distribute because I'm distributing twice. I'm distributing my first term, then I'm distributing my second term. So I'm distributing twice, which means double distribute. A lot of y'all said you like this double distribute method better. Again, when you're doing your homework, if you do it and you get 2 wrong, switch to the box and see if that helps us. Okay, we good? We are done.